Okay. You had a question? Somebody, back this way. Right row, wrong person. Yes, James.
I was wondering if you could go over getting the resistance of 1, 2, 3.
Resistance of 1, 2. This right here, this 4. How did I get that 4?
Yeah.
6 and 12 are in parallel with each other, right? So we're going to use the laws for, what is that, Kirchhoff's laws, I guess, for determining resistors in parallel, which is 6, 1 over x, or with your calculator, it'd be 6x minus 1 plus 12x minus 1 equals, then you hit the x minus 1 key. Oh, you weren't here yesterday, that's right. X minus 1 key, and then you get your answer. So you might want to review yesterday's lectures where I went over that. So, but you got it now?
Yeah.
Okay, good question. All right, is anybody else on this one? All right. The only questions we can come up with is, if I give you something really hard, will you try and solve it in front of the class? No.
It's not hard.
Let me see. It's not hard. Well, then why don't you do it? Oh, that configuration.
Yes.
Yeah, I'm going to do something like that. Okay. Yeah. No. It was a good question. That was a really good question, and it's a good example. Let me have that in case mine doesn't do it for you. Then we'll definitely want to do this. Yeah. Good job.
I can at least draw.
Well, I've got one that's even harder. We'll see how this works. All right. So we'll go black. I don't know why I'm doing this to myself. Yes, it does end eventually. All right. Givens. Let's see. 24 volt. We have 12 ohms, 6 ohms, 6 ohms. Okay, I see a pattern here. 6, 6, and 4 ohms. Again, I think the best way to do this would probably be for me to do it up on the board, but then you can go back and look at this because you need a lot of real estate here to do this. All right, so given this, and I do want to let you know that some good news for you. As far as I can tell, in all the Q&As that I've read, the FAA does want you to be able to do series parallel circuits to the extent that you can take any one of take one like this with all of the resistance and get R total. They never ask you to go back out. So I do. Because
Go back out.
Say that again.
fill out the voltage and amperage.
Oh.
So all right, so what are we going to do here? So hopefully you have this written down because we're going to lose it as I scroll because we can't look at everything at the same time. But we have to simplify, right? All right, so without trying to take up too much real estate here. Yeah, got that one, got this one, and this one. And this one. Correct?
Yes.
All right, so going back through, this is going to be 12 ohms, 6 ohms. Top one was 6 ohms, and this is 4 ohms. How many ohms is this right here? 3. We can use that one formula where it's if they're even, that you just add them up, divide by the number that are. So 3 ohms. All right, so we can simplify it one more time because we're not done simplifying. Because, everybody following so far?
No. Well, what did you just do with this two parallel?
6, 1 over x plus 6, 1 over x, 1 over x equals 3. There is a secondary formula that I told you where it's the number, if they're all the same, then you just divide by the number that there are. So 6 divided by 2 is 3, but go back to the simple way of doing things, the way we know. All right, so simplify one more time. So we have 12 ohms, 6 ohms. How many ohms here? 9 and 4 ohms. So we can kind of work on our EIR total. I already told you that we have 24 volts total. So what is my total resistance?
The reason why we got 9 is because it's a series, not parallel.
6 is in series with 3. So what is my total resistance?
I got it. 1.63 ohms.
He says 1.63 ohms. First thing I'm going to do is look at, it's going to be less than 4. So say that's a pretty good probability. Anybody, I don't have it in front of me. Anybody do have it in front of me? 1.63, 1.63. Everybody's happy at 1.63? Well, then how much current do I have? 14.67 amps. All right, what can I fill out here on this bottom one to complete it off? Voltage, 24 volts, 24 volts, 24 volts, 24 volts. And now we can finish up our current flow, which would be 2 amps, 4 amps, 6 amps, and this one is
2.67.
2.67. All right. Amps. Now note that we can take all of these answers for R1, R2, and whatever that one is. That'd be 1, 2, 3, 4, 5, R6, and just carry them right up top, right? Because that is already the answer. We're done. We're done with these. Everybody follow that? Okay. So, told you, got to keep it neat. I already blew it. All right, but now we got to work our way back up. Back up. So, here we have 24 volts, 2.67 amps, and 9 ohms. As the battery feeding into this series circuit. So what can we say is true about that? 2.67 amps, 2.67 amps, 2.67 amps. All right, and now we can finish that off. So that's going to be, voltage is going to be, wow, go ahead. 2.67 times 6 equals 16.02. And E equals I times R, so 3 times 2.67, 8.01. Yes.
After we got the totals for EI and R for the series parallel, we can make each resistor 24 volts because it's a parallel.
Up here, up top? Yeah. Or here? Yeah, because it's parallel.
Right, that was the next step.
Yeah.
Okay.
Okay, so we've completed this. So this is R1, this is R2, this is R3, R4, R5, R6. This is R1, R2, R6. This is R3, and this one is R4, comma 5. And that makes this one R3, 4, and 5 right there. Yeah? Okay. If anybody's lost, you gotta speak up. Otherwise we get all the way to the end and go, okay, wait, I don't understand how you got the first step. So just speak up. It's quite okay. All right, so looking at this, R3 is done right here. We just carry it back up to here. It's already done, right? Okay, but now we got R4 and 5, which is the battery feeding into this one. So what can we fill out there? Voltage. So voltage is 8.01 right there, 8.01 volts. So 8.01, 8.01, using Ohm's law to solve for the remainder. That's E equals I times R. So I want to know I. So it's E divided by R, 8.01 divided by 6.
1.335.
Say it again.
1.335.
1.335 amps. And this would be
The same.
same, 1.335 amps. And 1.335 plus 1.335 equals 2.67, so that checks out. So boom. It's just that simple. So the one that Sherman handed me, similar, but different. Of course, he didn't give me any values, so I'm going to make my own values. Okay. 1, 2, 3, 4. All right, give me a voltage.
1.
Nope. 28 volts. Ohms.
100. 75.
Okay, there we go. R1 and R2 are in parallel. R3, R4
Series.
are in series with each other, but in parallel with 1 and 2. If I wanted to redraw it in a way that looked different to me, this is R1, R2, R3, R4. So it's just like that. So that makes that 20, 100, and 295. Everybody agree so far? So that makes our total less than 20. $15.78, because I have 7754, so I go 15.8. We'll go 15.8 ohms, and we said it's 28 volts, and so that would be 28 volts. That would be 28 volts, and that's 20. Oops, we do have to do. Yeah, we already combined it here, really. Because technically we should have wrote it one more time, so I'll just. This is the combination of the two. Everybody follow what I did?
No.
Instead of writing it a third time, I just combined. So this right here is R34, 28 volts. All right, current then is 28 divided by 15.8 equals 1.77 amps. Everybody agree with that? Am I by myself? Yeah, crickets. Crickets? Okay. All right. What'd you get here?
1.4 amps.
1.4.
0.28.
0.28 amps and
0.095.
say again?
0.095.
Anybody agree with that? Disagree?
Yes.
Everybody agree? Okay. So there we go. We've already finished R1. We've finished R2. We've got R total. We just got to move this back up into here. And so how many amps are going to go through right here? 0.095, because this is my battery right here supplying power right that way. So amps stay the same, 0.095, because it's series, 0.095. And now we can use Ohm's law to solve for the voltages. So the voltage here on R3 is 7.125, and the voltage here is 20.9. Okay, so 20.9 plus 7.125 equals right about 28. So that checks out. And this is 0.28 amps. This is 1.4 amps. So 1.4 plus 0.28 plus whatever's left over, 0.95, goes through the entire series circuit we have left, comes back around for a total of 1.77 amps. Handout?
Let's do it.
Okay, before I hand this out, I set down the crack pipe.
So he thought.
I just don't know where I did the. Brought the wrong things in. Oh, no, I didn't. Let me see. No, that's the stuff you already did. This is the crack pipe version. Nothing against those of you who are into that sort of thing.
It's homemade.
So I did solve this one. And the secret to solving this one, I told you, you've got to keep it neat. Where's my solve? There it is. So I have the answers. It took me 6 pages. So every single page, every time you reduce it, I made another page. It was the only way I could do it. I tried it like on 1 or 2, and every time I'd get halfway through, I'm like, okay, where was I again? So that's if you solve it all the way down and figure out the R total, then work it back out. Because you can collapse, and get R total. Quite simple.
For multiple resistors.
For all these series parallel resistors. It's going back out where, okay, this feeds into those two. This is the battery for that, where it becomes incredibly difficult. So I will hand this to you for fun. This is the realistic one, where it is just 4 resistors. So this you should be able to do with no problem.
Sweet.
And I don't even know what the answer is to this one.
KitchenAid.
What's that? Need another one? Do you want me to hand you the bonus crackhead one?
No.
It's not that hard, it's just time consuming.